Hello dear children, this is our 8th lecture on kinematics. In the previous class, we started motion under gravity. Dear children, as we have studied that under motion under gravity, we have 3 cases. The first case is height to ground, second case is ground to ground, third case is height to ground. In the previous class, we covered from height to ground. In today's class, rest of the 2 cases, that is ground to ground, height to ground, which we are going to cover. Children, to study this motion under gravity, few conditions are there which we discussed in the previous class. Let us recall those conditions. Then only these concepts, whatever we are studying, are applicable. Okay, fine. What is the first condition, children? The first condition is that throughout our discussion, air resistance is neglected. Of course, practically it is not possible, but theoretically it is possible, right? So, air resistance is neglected completely. Second one is, whenever we are throwing a body's vertical upward direction, okay, na, make sure that maximum height attained by an object should be less than that of the radius of the earth. And the third one is that, so whenever we are throwing a body with a certain velocity, make sure that velocity should not be near to the escape velocity. So these are the 3 conditions which we are going to consider throughout our discussion and we are going to follow. Okay, fine, children. So in a previous class, as I told you that yes, we covered, it's a ground, what we can say height to ground. A link is given in the description, just go through that link. Okay, fine. So in today's class, children, here we are going to discuss about actually ground to ground. What is that called? Ground to ground means what? So we will be standing on a ground, okay, and we throw an object like this. So what happens? Yes, it will go, it reaches at a certain maximum height. Again, it starts reverse journey. So here there are 2 cases. The first case, body is going from ground to height, and what is happening? From there again it is coming to the ground only. So this is what actually ground to ground only. So this is a case we are going to discuss. So in this case, what is the time of ascent, what is the time of descent, what is the maximum height attained by an object, and the time of flight, velocity at any instant, and how can we calculate the displacement at any instant, and how the acceleration time graph, velocity time graph, displacement time graph. Okay, we will discuss, and after that we also will cover from height to ground case also. So today actually we are going to complete the session related to the motion under the gravity. Fine, children. Now look at here. So this is a situation what we are going to discuss. So children, let us assume that an object of certain some mass m, let us say some mass m, is thrown from this ground. Children, here this ground is for us reference point. And as we all know that, children, so from this reference point, children, the measurements taken above this reference point are taken as a positive, and below this reference point or say reference line, okay, na, taken as a negative. So this point we should keep in our mind, then only concepts are very clear to us. So from this point A, the body is thrown vertical upwards. Here U is called speed of projection or velocity of projection, okay, and it reaches at a maximum height, let us say point B. But at a max, children, as the body is going vertical upward direction, the speed, so called velocity, also keeps on decreasing. After reaching maximum height, its velocity becomes 0. Again, then it starts falling down, okay. And at a point, let us see that it is a point, it is point where it is going to hit the ground. It has certain velocity right here. So let us say its velocity is v. This is called velocity of collision. Yeah, don't get doubt actually. Some of you may by seeing this diagram you may get doubt. Sir, is the body is going like this vertically, then is it going horizontally sometime, again coming back like this? No. Just to have a clarity I drew like that. Otherwise it is going like this, again coming along the same path. Just this is a just assumption. Why? To have a clarity. Children, it is not going like this. No, it is not like a U shape. Please try to understand. It is going vertical upward direction, along the same path it is coming back. Just to have a clarity only, it was drawn like that. Clear? Fine, children. Here one important point to be noted here. So this is, here I wrote UA is equal to VC. but UA is not equal to VC. Some of you may get one doubt actually. So what is this? How, if it is equal means why again it is not equal? Children, so the speed of projection is equal to the speed of collision, but velocity of projection is not equal to the velocity of collision. Velocity of projection is not equal to the velocity of collision. Why? Children, because at this point A, velocity direction is upwards. But where at a point C, velocity direction is downwards, because velocity is a vector quantity, right? So they are differ in the direction. Magnitude might be same. That magnitude of velocity only we can call the speed. That's what I said, that speed of projection is equal to speed of collision. But velocity of projection is not equal to the velocity of collision. Clear? Fine. And then one more point we need to understand, children. So let us say this is the first journey. Let us say the first journey, upward direction. This is downward direction. Children, as the body is going vertical upward direction, still here, if you can see, it is a direction of velocity. But still here, acceleration due to gravity is downward directional. Means here, this is a retardation. This is retardation. Body is retarded. Body is retarded. Why? Because speed and acceleration both are in opposite direction. At a maximum height, velocity is 0, but still acceleration due to gravity will be there. That too in a downward direction. In the second case, downward journey, if you can see, yes, the velocity direction and acceleration direction both are same. That too downward direction only. So this is retardation case. This is acceleration case. But in three cases, if you can, of course, this is the third case where the velocity is 0, but still body has some acceleration. Okay, fine. In these three cases, if you can see, means at any point during its journey, if you can see, acceleration due to gravity is downward direction only. Means what? Downward direction. So that's what acceleration due to gravity is always taken as a negative. So this point also we should keep in our mind. Okay, fine. Now let us try to discuss what is a first time of ascent. Okay, then maximum height reached by a body. Then we'll discuss time of flight also. Okay, fine, children. Now you tell me what is the time of ascent. Children, as a body is thrown vertical point A to point A, it is thrown, you know. So it takes some time to reach a maximum height, right? So this time taken only we can call it as a time of ascent, children. So the first one we are discussing about time of ascent. Time of ascent. So children, what is the time of ascent, children? The time taken by a body to reach a maximum height. To reach a maximum height is called what actually? Time of ascent. Clear? Yes. So look at here. As a body is going from A to B case, try to understand. It is a A to B journey from A to B. So it has the initial velocity. Is it positive or negative? Positive. Why? Because the velocity is upward direction. Okay. But at a point B, if you can see, its velocity is 0. At a point B, maximum height 0. At a maximum height I am talking about. And A is equal to minus G only. Now let us take a first equation of motion. V is equal to U plus AT. Okay. V is 0. U is what? U only. Plus in the place of A minus G, and this is going to be a time of ascent. So now this is U minus GTA is equal to 0. From this, children, GTA is equal to U. So time of ascent now is equal to U by G. So this is how we can calculate the time of ascent. If you can notice, children, here time of ascent is directly proportional to the initial velocity, directly proportional to the velocity of projection. If you can throw a ball with a more velocity, obviously it takes more time to reach a maximum height. That time taken only we can call it as a time of ascent. Is the point clear, children? Is the point clear? Okay, na? Just note down. Now we will calculate the what maximum height reached. Maximum height reached. Is it copied, children? Done. 3, 2. Okay, fine. Now maximum height reached, children. This is also very important for examination point of view. Okay. Now the second parameter, whatever we are going to discuss, is maximum height. What is that, children? Maximum height we'll see, and even we also will see on which factor does it depend? Maximum height. So A to B, right? A to B is actually what? Maximum height. Okay. Anyhow, velocity is positive because upward direction. Okay. And okay, maximum height S is equal to, it is plus H only we will take, because from here to here we are taking vertical upward direction, and A is equal to minus G. So at a maximum height, final velocity will be 0. Now let us consider the second equation of motion. V square minus U square is equal to 2AS. So this is 0 square minus U square is equal to 2 minus G, it is H. So minus U square is equal to minus 2GH. Minus minus cancel. So H is equal to U square by 2G. So this is a formula to calculate the maximum height attained by an object. Here also, if you can see, for a given height, G is a constant, right? So here H is directly proportional to the square of the initial velocity, so called velocity of projection. With more velocity, if you can throw a body, obviously it can take a more height. The maximum height will be more. Children, same formula we also can derive by using law of conservation of energy. Children, anyhow we are not going to consider the air resistance. Air resistance is neglected. So obviously if you can consider the law of conservation of energy, according to law of conservation of energy, children, energy at a point A must be equal to energy at a point B, because as per the law of conservation of energy. So at energy, what kind of energy will be there here? Kinetic energy. So kinetic energy at a point A equal to potential energy at a point B. Okay, so kinetic energy half mu square, potential energy mgh, maximum height is h, m cancel. So here h is equal to u square by 2g. Children, same expression we get, same expression. So whatever the concept, which of course this generally we use this concept in our work power energy chapter actually, but what I mean to say is that yes, we also can derive the expression for maximum height attained by a body. So that is what actually h is equal to u square by 2g. Is it clear, children? Just copy it. This is a second parameter. Okay, now what happened? Yes, it takes some time to reach maximum height. We have calculated the time of ascent also, and even we calculated the expression for maximum height. Now it has to come back to the ground, right? So for that it takes some time. That time only we can call it as a time of descent. So the third parameter is time of descent. Time of descent. So what is the time of descent, children? Yes, the time taken by an object to come back, means return journey, I can say that. So from maximum height to the ground, from where the point is projected, again it has to come back to that point only. So during this journey, it takes time. That only we can call it as a time of descent. So means what? Time of descent means from where to where? Yes, it is B to C journey. B to C. So from here at a point B, so here this final velocity is going to be the initial velocity, children. So for in this B to C journey, children, what is its initial velocity? 0. So initial velocity is 0, and here distance is going to be minus h. Why minus h? Because as per the sign convention rules, now the downwards we have to take the displacement vertical downward direction. So downward directions are taken as a negative. Okay, and A is equal to minus g, and the time is going to be time of descent. Now let us take the second equation of motion. Of course, in the second case, we consider third equation of motion. Now second equation of motion, what is that? S is equal to ut plus half a t square. In the place of s, minus h, anyhow this term will be 0 because u is 0, and plus half minus g time of descent square. So this is minus h is equal to minus g by 2 into td whole square. Minus minus gets cancelled. Now let us make a time of descent as a subject. So this expression can be written as TD square is equal to 2h by g. So from this, time of descent is equal to square root of 2h by g. Children, this expression you can calculate only when the maximum, the height from where the body is released. If you know the h value, then only you can. But look at here, already we know the, see this is okay formally, and we also can have a one more form for this time of descent. So h value we know, right? What is the h, children? H is equal to, already we got u square by 2g. Now let us substitute in this case. So we get time of descent is equal to square root of 2 by g. So in the place of h, now we are substituting this. It is going to be u square by 2g. 2 cancel. So now this will be u by g whole square. U by g whole square. Square root get cancelled. So time of descent is equal to u by g. So here time of descent also is directly proportional to the velocity of projection. And here you may get surprised. Already we got time of ascent is equal to u by g. So which means what, children, here? Yes, as we neglected the aid friction, children, whenever we neglect the aid friction, time of ascent is equal to the time of descent. Time of ascent is equal to the time of descent. Clear? You may get one doubt. Sir, what if air resistance is not neglected? Can we still is time of ascent is equal to time of descent? No. Then which is more, which is less, children? Can you guess? Children, when we considered, if you don't neglect the air resistance, do you think that time of ascent is equal to time of descent? Obviously no. Okay, as both are not equal, then which one do you think is a more, which one do you think is a less? Just you comment your answer, and the next video we will make on that only. Okay, so whether time of ascent is more or time of descent is more. Okay, fine. So this is third parameter for time of descent. Clear, children? Okay, fine. Now we go for the fourth parameter related to this discussion is time of flight. Time of, not light, children, time of flight. Okay, so far we discussed time of ascent, time of descent, and of course maximum height expression also we have done now. So this is time of flight, children, FLIGHT. So we can denote with a T. What is time of flight, children? The time in which a body remains in air for some time is called time of flight. Means in this case, if you can see, children, the body is thrown at a point A, right? It is going like this, reaching maximum height. Again, it is coming back to point C. Means in this total journey, it's going again coming to go up to come downward direction. It takes a time, right? That only we can call the time of flight. The total time taken. Or simply we can say that the time for which a body remains in air is called time of flight. Now let us derive an expression for time of flight. Okay, so children, so during the total journey means what? A to C. Its journey is A to C. Children, now what is the displacement? 0, right? Because it is coming back to the same point. Displacement is 0. Okay, A is equal to minus G. That's fine. And initial velocity, it will be there. Okay, try to now let us take S is equal to ut plus half a t square. So this will be 0, u, time will be capital T, a is going to be minus g, so minus g by 2 into t square. So this we can write gt square by 2 is equal to ut, t square cancel. So now we need expression, right? T is equal to, get this 2, get this g. So it is 2u by g. So this is expression for time of flight. So here also time of flight is directly proportional to the u. Okay. But children, time of flight is nothing but what? You can see here, the sum of the time of ascent plus time of descent. That's what we got, right? U by g plus u by g. So this only 2u by g. Okay, fine. And here one common factor is there, children. So either time of ascent or a time of descent or a time of flight, maximum height. So these parameters do not depend on mass of an object. Mass of an object, very important. Mass of an object. Mass of an object. Okay, na? Just copy this. Now we'll see. Okay, this is all the things which we discussed. But how can we calculate the velocity of an object at any instant? Displacement covered by an object at any instant. So the two parameters are left in the second case that we'll cover. Just copy this. Done, children? 3, 2, 1. Okay. Fine. So the fifth parameter we are discussing, velocity of an object at any instant. At any instant. Okay, na? So means what? This velocity we are seeing for velocity for at any instant. So v is equal to, children, we know that u plus at. So after time t, children, yes, velocity will be, let us say vt. So it is thrown with some velocity, u will be there, a is going to be gt. So this is how actually we can calculate at any instant, because we are throwing with a certain velocity. Let us say u is equal to 20 meter per second example. So g is equal to, let us say, 10 meter per second square. Okay. After, for example, you if you want, for example, after 1 second, what is velocity? You can substitute here. So you will get, this will be 20 minus 10 into 1. So 20 minus 10, this will be 10 meter per second. You make it one out. Sir, what will be its velocity after 2 seconds? After 2 seconds, 10 into 2, 20. 20 minus 20, 0. Means what? After 2 seconds, velocity 0 means what? Yes, it is reaching the maximum height. Okay. And if you can substitute after 3 seconds, you will get a minus value, which means what? Yes, body started reverse journey back, means downward direction. So it's a negative only. Got clarity? Fine. Children, this seems to be like, it's a linear equation, right? It is. Okay, equation for straight line. So y is equal to mx minus c, right? Mx, okay, mx plus c, let us say, mx plus c. So here in the place of m, what is there? Minus g. So try to understand, children. So how can you get a slope for this? How can you get slope? Look at here. So just differentiate this. dvt by dt is equal to du by dt minus g is a constant, dt by dt. Anyhow, initial velocity is a constant, right? So it's a differentiation 0. So this dv by dt is what? Actually acceleration a. This value is 1 dt by dt. So minus g. So slope of what? This formula, the slope of this equation is what actually? For this equation, it is a minus g. That's what? At any instant, children. At any instant, acceleration is always negative. Now let us see how the velocity time graph will be there. How the velocity time graph. Look at here. So here is time. Okay. So let us say velocity is taken on y-axis. It is 0. So means total journey we are talking. It is starting from A, going to B, coming back to C. Means A to B, children, it has a maximum velocity here. Maximum velocity. At a point B, 0. At a point C again maximum. But A to B, its velocity decreasing. B to C, its velocity is increasing but in a negative direction. B to C, downward, negative direction. So it has a maximum velocity. Let us say it's u. Okay. As time passes, so its velocity decreasing. This is a point where it's 0. Means this is only we can call it the time of ascent, right? Time of ascent, u by g. At this point only, its velocity will be 0. But still, as the time passes, what happened? Its velocity increasing but downward direction. It will be maximum again. Maximum. So this is actually total time of flight, 2u by g. So this is what actually is a negative. It is a minus u, it is a plus u, children. So this is how actually velocity time graph will be there for the case where the body is thrown from a ground, again it's coming back to the ground only. And with this formula, we can calculate the velocity of an object at any instant. Okay, now so we get a straight line. Right? So linear equation. Okay, now fine. Now we see, children, how can we calculate the displacement of an object at any instant? So displacement, not now velocity. Okay, now so till now we discussed about the velocity of an object at any instant. Now we are going to discuss the displacement of an object at any instant. So it's the sixth parameter in this case. So this is displacement of an object at any instant. So S is equal to ut plus half a t square. So as we know that a is equal to minus g. After time t, let us say displacement is st. So this is st is equal to ut minus half gt square. Now if you can see, this is quadratic equation, right? So what kind of graph we are going to get for a quadratic equation? Yes, we'll get a parabola. If the equation is quadratic, if it is a linear straight line, if it's a quadratic equation, we'll get a parabola. Now let us see, children. And okay, why we are getting a parabola? Okay, mathematically it's a quadratic equation we'll get, but conceptually also we'll see. Children, so A to B, B to C, this is a complete journey. So A to B, what is happening here? Displacement is increasing. Let us say distance, if you talk about the magnitude, increasing. At B, maximum. Again B to C, it is decreasing. So A to B is increasing, B to C is decreasing. Okay, it's not linear, it's a t square, right? Okay, now look at here. So let us make a graph for this. Okay, so here time is taken on x-axis, children, because it is a independent, and height is taken here, h, this one. So when time is 0, initially when time is 0 at this point, children, what will be its height? 0. When u is 0, children, when u is 0 initially, what will happen? You will get a half gt square. Means what? That particular graph passes from the origin. Okay, so slowly A to B, it is increasing, non-linear manner, increases, reaches maximum. This is maximum, it is S max, maximum height reached. Again B to C, let us say this point A, it is the point B. B to C, yes, it is decreasing. So here the velocity is downward direction, children. Velocity will be downward direction. Here it's upward direction. And you all see, children, it's a displacement time graph. What is the slope of displacement time graph gives? Velocity. Now look at here. Here at any point here, A to B journey, if you can make a tangent, if you'll find the slope, fine, try to understand. Slope. So here is a theta, right? So theta is less than 90 degrees. Means what here? Slope is positive here. A to B, slope is positive, means velocity is positive. At B, if you can see, slope is 0, that is velocity also 0 at point V. But whereas here, if you can see during downward journey, yes, so this is theta is greater than 90 degrees. So means what here? Slope is negative, hence velocity also negative. Okay, children, so this is how actually we can calculate the displacement of an object at any instant, and this is a related graph. And you make it one doubt, sir, we have seen a velocity time graph, displacement time graph. What about acceleration time graph? Hey, acceleration time graph, it won't change at all. Look at here, but still I'll draw. So this is time, this is acceleration, because 0. So this will be, because throughout the journey, children, g is equal to minus L, right? 9.8 meter per second square. So g value remains constant and it is always downward direction, so it is a negative. So it is a constant. So that's what we get acceleration. Sorry, it's what actually? It's a acceleration time graph. So acceleration remains constant, means we'll get a straight line parallel to the time axis. On the negative side, why? Because as per the sign convention, acceleration due to gravity is downward direction. Clear? So just copy this. So this is a case 2 where it is a ground to ground. Now we'll discuss height to ground. Okay, so copy it. V is equal to U. Actually, now here is a case 3 where it is see, case 1 is height to ground, case 2 is ground to ground, case 3 is what? height to a ground, children. Try to understand. Means let us suppose we are standing on at some building. From there we are throwing a body like this. So it is going like this, reaches maximum height. Again it comes back and it hits the ground with some velocity. So called velocity of collision. And so one important point, it is not mandatory that reference point should be always taken on the ground only. No, from the point from where you are throwing the body, that can be a reference point. Now for us, reference point is here, this building height. From this top of the building is a reference point. So here vertically downward direction, quantities are negative, upward direction, quantities are positive. Now what are we going to calculate here? Now we are going to calculate two parameters. One is time of flight and second is velocity of collision. Velocity of collision, not velocity of projection. That is known actual to us with what velocity we are throwing. We have to calculate the velocity of collision. Clear, children? Fine. So now we discuss the first parameter, time of flight. Time of flight. Children, it will be very interesting. Time of flight. Should have some patience. Okay, fine. Now, so look at here. Let us take a S is equal to ut plus half at square. Children, if t tends to capital T, means the time will become a time of flight. Okay, in that case, okay, there will be some value for u also. But what is a S will be? S will, look at it. From this point it is thrown. So it is going like this, coming back like this, again coming back. But if you can, children, so this vertical distance covered is equal to this vertical distance. But this is a plus, this is a minus. So these both will get cancelled. So if you want the total, what we can say S value. So first you should add this plus S, okay. Again from here to here it is a minus S, okay. And from here to here it's a height, that will be minus height only. So both will get cancelled. So S is nothing but actually here is minus H, because these two vertical distances are equal and opposite, will be cancelled. So now what is the total displacement covered by an object, which is equal to the height of the building. So now substitute here. So it is minus H is equal to ut minus half g t square, because negative, right? A is always negative. Now bring this term this side, children. So this is going to be half g t square minus what can we write? Okay, ut minus h is equal to 0. Children, this g by 2 you can take a common, so it can be written as t square minus 2, sorry, this is a capital T, capital T, this is 2u by g into t minus 2h by g. Both are equal. These both are equal. Why we wrote in this form, So it is in the form of ax square plus bx plus c is equal to 0. So for this, children, how to find out the roots here? We know that roots can be minus b plus or minus square root of b square minus 4ac by 2a. Just you compare now. So here a is equal to 1. So b can be minus 2u by g and the c can be here minus 2h by g. Okay, now let us substitute in this. Of course, here we need to get the roots, right? So time t, for a time we want actually. Okay, now so is equal to plus or minus. So first minus b. So minus into minus plus. So this can be written as 2u by g directly plus or minus square root of b square. This square is going to be 4u square by g square minus 4ac minus 4. A is 1 but c is again minus, right? So minus into minus plus, it will be 4 into 2h by g by 2 into a. A is 1 only, so it can be 2 only. So I think here we can take 4 as a common. So look at here. So 2u by g plus or minus 2, if you can take a common, this is going to be u square by g square plus 2h by g by 2. So here I think this 2 you can take as a common. This 2 we can take as a common. This 2 will get cancelled. Children, time won't be negative, right? Let us say this is term x, this is term y. Children, if this term is greater than that of this, okay na, So there will be a chance of getting a minus for a time, right? But time won't be negative, so we should take a positive one. That is what actually. So time is equal to u by g plus square root of u square by g square plus 2h by g. So children, this is the expression to calculate the time of flight. Let me write time of flight. But children, here one important point. For look at it. If children, for suppose if u is equal to 0, if u is equal to 0, children, what happens? Complete this term will be 0, this term will be 0. Then time of flight will be 2h by g square root. Means what? You make it out, sir. How u will be 0, sir? We are throwing from here. No. U is equal to 0 means what? From here. So this is a downwards journey. So this will become a case 1. Body is thrown from height to ground. Time of flight we got already. T is equal to square root of 2h by g. We got 2h by g. Square root of 2h by g. What if h is equal to 0? What if h is equal to 0? This total term will be 0. So this then time will become u by g plus square root of u by g whole square. So this both will get cancelled. So u by g plus u by g, then t is equal to 2u by g. Means maximum height. See, if h is 0 means what? This place is not there. This is not there. H is 0 means this is not there. Means the body is going up, coming here. Means it is hitting here only. It's like this. It is hitting here only. Which means what? This is the second case, right? It is like it's ground to ground. If it is the ground. See, h value is 0 means what? Simply it is a ground to ground only. So this is a beauty with this actually. So beauty of this expression is that, children. So we can get case 1. We also can get a case 2 here. So this is a time of flight where body is thrown from height to ground. This is a time of flight where height to ground. This is a time of flight where it is a ground to ground only. Is it clear? Just copy this. Now next one. Now how to calculate this v? V is what actually? Velocity of collision. Now that we need to calculate. Just copy it more. Done. Just you need to remember this actually. In fact, nowhere they'll ask you to derive this expression actually. But see, sometimes to just to confirm whether expression you got right or wrong. So you can check like this. You put u is equal to 0, you must get this. You place h is equal to 0, you must get this expression. Then it is right. If not, it is wrong only. Then redo it. Okay, fine. Now we discuss that. So velocity at a ground. Velocity at ground. At ground. Okay, children, fine. Now you with the velocity u we are throwing upward direction. So upward direction it is a positive. Let us say it is hitting with the velocity v. So as this here it is downward direction, right? So it is a negative. So v can be negative, and of course a is minus g. Okay. And what about height? Yes. What about displacement? Anyhow, here this both will get cancelled. So remaining one this one. It's a downward direction. So here s also is going to be a minus h. Now here let us take a third equation of motion. V square minus u square is equal to 2as. So let us substitute here. It is minus v whole square minus u square is equal to 2 into minus g into minus h. So this will be v square minus u square is equal to minus into minus plus. It is 2gh. So v square is equal to, take this u square right side, it will become 2gh plus u square. So v is equal to square root of u is equal to square root of u square plus 2gh. Children, this is a expression to calculate the velocity of collision. Fine, children. Now children, you may get one doubt, sir, how can we calculate the velocity of collision if we are standing on a building and we are throwing some velocity? U can't be a 0. Still, this formula is valid. What if u is equal to 0? What if u is equal to 0? If u is equal to 0, children, yes, v is equal to square root of 2GH. V is equal to square root of 2GH, children. So this is a case where, yes, it is from height to ground. It is going to be first case again. It is going to be a first case. Okay, children. So this is motion under gravity. Children, maximum we covered here. Children, as one question, if air resistance is considered, time of ascent is not equal to time of descent. But my question is that when air resistance is considered, which one is more? The time of ascent is more or time of descent is more? Just think about it, comment your answer, and wait for our next class where we are going to discuss whether time of ascent is more or time of descent is more when air resistance is neglected. Children, as it is our new channel, we need all your support. So hopefully you like the video and subscribe, and even you can what we can say, suggest your friends to follow our channel. Okay children, thank you so much, all the very best.